Alright, section 8.2 today. 8.2 is about counting outcomes. So again, we want to focus on vocabulary for a second. We've got tree diagram and fundamental counting principle. Now, when are we going to ever use this? We want to be able to find different possibilities, and so they give an example where Antonio wants to buy a new bicycle, and so we want to know how many different styles are available, how many colors are available, how many sizes are available, and make an organized list. So over here in the ad we see mountain or 10-speed styles, red, black, or green, and then sizes 26 or 28 inch. So one way to organize that is a tree diagram. Now, tree diagram is exactly what it sounds like, a diagram that branches like a tree that will show all the different possibilities. So down here we see an example of a tree diagram. Notice we have style, color, size, and outcome. These are the different categories, and then underneath each category you have the possible outcomes. Now notice how on style they only list mountain and 10-speed once, but then under color they've got red, black, green, and then red, black, green again. Each color has to branch off of each style to show all the different possibilities. So as you can see, with each different choice we have to branch off again. We've got 26, 28, 26, 28, and so on. And so then here they list out the final outcome. At the top is a red mountain bike that's 26 inches. At the bottom it's a green 10-speed that's 28 inches, and in between are all the different possibilities. So if you want to know all the possible different outcomes, you'd count up how many there are to the right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we want to be able to build our own tree diagram. Now this has given people problems in the past before, so I want to do a couple of different examples of it. So you're going to roll a single die and flip a coin. Make a tree diagram to show all the possible outcomes. So we've got two different events happening here. Okay, we're going to roll a die. That's a single dice, by the way. And then we're going to flip a coin. So the first thing I want to do is list underneath my dice here all the possible outcomes. There's 6 sides to a dice, so we got 1, 2, 3, 4, 5, 6. And then when we flip a coin, we've got 2 possible outcomes, heads or tails, and each one of those possibilities has to branch off of each outcome from the dice. So we've got heads and tails, and from here on I'm just going to abbreviate that with H or T, make it a little bit easier. H, T, H, T, and hopefully at this point you get the idea. And at the end, the example that the book gave listed out all the outcomes to make it a little bit easier to read. So my outcomes are a 1 heads, 1 tails, 2 heads, 2 tails, 3 heads, 3 tails, and so on. And then when we get those all listed out, then we can just count up how many there are, and that will tell us how many possible outcomes there are. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's what a tree diagram does for us. Now for some reason this problem gives people trouble. Steve is going to flip a penny, a nickel, and a dime, make a tree diagram to find all the possible outcomes. I really can't stress enough how important it is to list out your event and then underneath it list your outcome. For some reason people like to try and put what the event is into the tree diagram, and it messes them up. So underneath the penny, I can either have heads or tails. Now after that, off of each one of those, I have to branch off and get the outcome for the nickel. So the nickel can have heads or tails after a heads for the penny, or a nickel can have heads or tails after tails for a penny. And then my other event is my dime, so I have to branch off of each of the nickel outcomes, and the dime can get heads or tails after each one of those nickel events. And again, I could take the time to list out my outcomes. But the nice thing about the tree diagram is you can just read right along the branch and it'll tell you. So you could get 3 heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. 1, 2, 3, 4, 5, 6, 7, 8. 8 possible outcomes. Now, as you can see, I mean, we only did events where there was 2 things happening in the first one and 3 in the second one, and it took us a little while to make those tree diagrams. So we want to find a shorter way, something a little bit easier. So this is where the fundamental counting principle comes in. It says you can find the total number of outcomes by multiplying using the fundamental counting principle. Now read in this key concept box. In words it says, if events M can occur M different ways and is followed by event N that can occur N different ways, then the event M followed by the event N can occur M times N ways. Sounds really, really confusing. Basically, if you want to take those variables out and kind of just state it in words a little bit, if you have more than one event happening, if you take the number of outcomes for each individual event and multiply them together, that gives you the total number of outcomes. So this is basically the same thing we just did a tree diagram for. If a number cube is rolled and a coin is tossed, there are 6 times 2, or 12 different possible outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Our tree diagram listed those out, but the fundamental counting principle can find the same thing just by multiplication. So in this example, it says in the United States, radio and television stations use call letters that start with K or W. How many different call letters with 4 letters are possible? So you've got 4 different events. You're choosing 4 different letters. That's kind of important. So we're choosing 4 letters. On the first one, it's restricting us to either K or W. So there's only 2 choices for the first one. But then after that, you can have any of the 26. So there's 26 for the second, 26 for the third, 26 for the fourth. Now, if you can imagine trying to do a tree diagram for that, it would be a very, very large tree diagram. So fundamental counting principle just says we can multiply the possible outcomes for each event. So 2 times 26 times 26 times 26 is 35,152 possibilities. Go ahead and take a minute and pause the video and try these your turn problems. If we look at A on the your turn problems, a hairdryer has 3 settings for heat and 2 settings for fan speed. So there's 2 different events here. You're picking out a heat setting and you're picking out a fan setting. There's 3 heat settings There's 2 fan settings. Fundamental counting principle tells us I can multiply those, and that tells us that there are 6 possibilities overall, 6 possible outcomes. Now that would not be a hard one to do a tree diagram for if you wanted to, so you could see what those outcomes are, but fundamental counting principle says we don't have to make that list, we can just multiply. For part B, restaurant offers a choice of 3 types of pasta and 5 types of sauce. And then each pasta entree comes with or without a meatball. So I've got 3 choices for my pasta, I've got 5 choices for my sauce, and then I've got 2 choices for my meatball, either with or without. So if I multiply these together, 3 times 5 is 15, and 15 times 2 is 30. So there's 30 possible dishes that I could have. Now, to kind of link this together to what we were working on in section 1, because this all links back to probability. The probability of winning a lottery game where the winning number is made up of 3 digits from 0 to 9 chosen at random. So, the first step to finding probability was to find the number of outcomes. So, there's 10 choices for the first digit, 10 for the second, 10 for the third. Fundamental counting principle says multiply those together. That's 1,000 possible outcomes just for 3 digits. And then your probability of picking that one winning number is going to be 1 out of 1,000. So that pretty much covers everything that we're going to talk about in section 8.2. Go ahead and try those 4 through 8 under the guided practice in your notes so that I can see that, and come to class ready to do some work.